Guys, welcome back to the CC scripting course. I'm Casual Code, and in today's video we're doing the third module of the series. If you've missed module 1 or module 2, I recommend you go back to my channel and watch those. However, there's a big but to it. It only depends if you're kind of new to Roblox Studio, which I assume some of you guys are, and in that case you want to watch the at least you want to watch module 1. Module 2 is very basics, but then module 3 will kind of get deeper into Roblox coding. So if you're new to coding in general or just Roblox Studio, I'd recommend you go ahead and watch those two before watching this one. So in this video, what we're going to do is I'm going to go over loops, data types, and data methods in Roblox Studio. And then we're going to do a short introduction to Lua U math. We're going to do some string conversions, string concatenations and stuff. And then we're going to work with some other stuff like enums. And we're going to go a bit over sounds in Roblox Studio as well. So just to get started, I want to go over some basic examples of loops, and this also kind of covers data types and data methods. So in Roblox Studio, I've gone ahead and opened a empty base plate, and I'm going to insert a script into ServerScript servers. And then within the script, I'm going to zoom a bit in first so you guys can see. And then I'm going to delete the print hello world. So basically in Roblox Studio and in essentially every other programming language there is to be found, you'd find loops. And loops basically, it just runs certain code over and over and over, like the amount of times you want it to. And there's a few different methods of doing loops. And probably the most known one is the one I'm about to cover, which is an I loop or a for loop, if you want to call it that. So what we're going to do is, first of all, we're just going to go two lines down here. We're going to make the actual loop. So we're going to do for index, comma value, like this. So type the for, which is the keyword for a for loop. And then index, comma value, I'll talk a bit about in a second. And then do in pairs, and just leave this empty for now, and then do. Once you press enter, you should see an end come up here. If it's not there, then just type an end manually. Now, what we can do in here is we can add an empty print statement for now. So this is temporary. We're going to need to pass in some values for this to work. So essentially what's going on here is we're saying for each index and each value in pairs, so they go in pairs together within some table here. It says it returns an iterator function and the provided table for use in a for loop. And it's saying a bunch of like numbers up here and variables, whatever. This is just a total, but we need a t, and t is basically a table. So for each index, which is a number in a table, so the first number would be 1. You see in most common programming languages, it would be 0, but in Roblox it starts at 1. So the very first value that would, the very first index, sorry, we see would be 1, and then the value would be the value that's set to that number. So this might not make sense, but let me make it more clear for you guys. So if we have a table up here, we could say local scores, like this, and then define a table here. Then now we have a score table, and if we just go down here and we say within these parameters here, we say scores right here. So now it's saying for each index and value that goes in pairs in scores, do. And then it's going to print. And this, essentially, this print is going to run for each pair that we can do. For each pair that we can make within scores, this print would run. So if we can make 3 pairs, then this print function will only run, 3 times. If we can make 5 pairs, then it will run 5 times. And that's the beauty of loops, is that this will not run infinitely, and this will only run when we're trying to pair these index and values up. So right now, we'll just give scores some values. So we can say the first score is 10, and we can say the next one is 50, and then 100. So we basically have our score table here with 3 different values in it. We have the very first value, which is just going to be 10, which is also going to be the index of 1, because this is the first index. It's the first thing in our table. Then we'd have the next one, which will be the index of 2, and then this would be the index of 3, because 1, 2, 3, it's the values in order. And then the actual value for the index will say if this is index 1, then the value will be what it is. So in our case, it's 10. So for index 1, the value would be 10. So if we go ahead and print both the index and the value, and we go ahead and run this game, what we'll see down here in the output is, it might be kind of small for you guys, but it basically says 1 and then 10, because we're telling it to print the index first. The index is 1 and the value for the index 1 is 10, like up here. And then we have index 2, 50, and index 3, 100. So that is essentially how you do for loops. More commonly, you'd probably want to work, well, generally you work with tables in some sort. You can also work with, say, if you're looking to loop through everything in workspace, what you could do is you could do workspace get children, and then this gets everything within workspace. So for each element inside of workspace, it's going to print the index comma value. So if we go ahead and run this, we'll see the first index, or the first thing in workspace when we open it up, is the camera. So the index is 1 and the value is the camera. The next thing is the base plate, or in this case it's mixed up here, but the next thing was the base plate that it loaded, and then it was the terrain, and then it was the spawn location, but it's kind of messed up here. But you guys get the point. So next we can talk about some data type examples. And I kind of covered some of these in the last module, so we'll quickly just go through this. So to set a string in Roblox, you say local, and this is not just to set a string, this is to set a variable. You say local, and then we give it a name. We give this variable a name. We'll just say name in our case, or we'll do player name, like this. So this is our player name, and then we do equals because we have to give this variable some sort of value. So that player name will be equals to whatever is after the equal sign. So we can just define a string like this, and we could say Chris. So now the player name is Chris. So whenever we say player name, it knows that it is a string because it's after this. And if we do print player name like this, it would print Chris because it prints whatever player name is, and player name is Chris. Then you got numbers, which is the same thing. You can do player score, which is then going to be, say, 100. So then Chris's player score would be 100. We can do booleans, and boolean is either a true or a false statement, kind of. So we can do local is player alive. We can just say true, or we can say false, like this. And this is basically just a boolean, and you use these a lot in your game for checking certain things. If you have, for example, a minigame, you want to check if the minigame is finished. If it's not finished, then keep it running, else, restart the cycle, make a new minigame. And then we have some other things in Roblox Studio, which these you're going to use a lot. I mean, all this that I'm showing you right now, you are going to use when you start coding with 100% certainty. The next thing is we're going to talk about vectors. So Roblox Studio, we have vector 3 and we have vector 2 as the most common ones. So vector 3 is basically 3 dimensions, so x, y, and z axis. If you're good in math, or if you just had math in school, you know that it's 2. It's the x and the y axis. But in Roblox Studio, since it's 3-dimensional, since it's a 3D game, you have, let me show you. You have the x going here, the x-axis. Then you have the y-axis going up and down. And then that's 2D. That's for vector 2. And then we have the last dimension here, this z-axis, which makes the game 3D. So in Roblox Studio, you pretty commonly you want to set a position of something. So you do vector3.new, for example, or if you already have a set vector 3, you just use that. But say we had a new vector 3, it's going to ask us for an x, a y, and a z. So if I just do 0, 5, 0, then in theory, what it should go to the origin point, which is going to be like, I believe it's above the spawn point, but I'm actually not sure. So if it's here, and then it would go like 5, something like this, up the air. So we can actually check this by making this part here anchored, and then we'll just call this the position part. and then we'll go ahead and reference the position part right here. So we'll say local position. We'll call it like this: position part equals to workspace, find first child, and then oops, get rid of that, and then type position part like that. So now we have our position part. So if it's findable in the workspace, then we know what this is. Else it's going to run an error for us. So then basically we can say that the position point dot position should be equals to vector3 dot new 0, 5, 0. So basically what we're telling here is that this part's position should be equal to this. So if we go ahead and run the game, then we can see that it goes to the origin, which is 5 studs under this certain place in the game, and then it goes 5 studs up on the x-axis, the y-axis, sorry. And then we could also say that if we wanted to go maybe 15 studs in the z direction, we could type in 15 and it goes 15. Instead it goes 5 up on the y, then it goes 15 studs on the z-axis. You also have C-frames in Roblox, which is basically more or less the same as positions. You have your position actually within the C-frame here. You have the origin position as well. But within the C-frame here, it basically says it here. Many people speculate like, okay, you know, what's C-frame? You can see that the value of C-frame actually changes when I move this part, or the position changes. Like when I do this, you can see the X position changes. When I then go ahead and rotate the part, you can see the orientation will then change like this. And this is because C-frame isn't really complicated. It's just the position plus the orientation of the part. So normally in Roblox, when you're setting a position, then it would just put the part to that position, but it would not take in account if the part should be rotated like this. It would not take this in account. It would just move the part to that position. So if we're going to run this, we can see it just does this. But if we want it to then face, we want it to rotate this way, then we'd have to use C-frame to count in orientation as well. The way you use C-frame, you just do C-frame.new. Same thing here. So then this is all about positions and C-frames. We can go ahead and just remove this. That was just a quick element. And then for 2D elements like UI, user interface, which you do in Started UI, then you want to work in 2D because for a UI element, if we quickly go ahead and add a frame, you can see this frame only moves in the X and the Y axis. It does not move on the Z axis. So therefore we should only use the X and the Y, and you actually don't use vectors for this. You want to use something called UDIM2, which represents a two-dimensional value where each dimension is composed of a relative scale and absolute offset. So all you should know is just when you use working with UI especially, I'm sure you can use this for something else as well. I haven't really dug into that. Then you want to use UDIM2 because it's a two-dimensional element. All right. So just to test all of these variables that we did up here, because I kind of got sidetracked from that, we just do print player name and then player score, and then the is player alive. If we go ahead and quickly comment this code out and clear the output, then we can see that it says Chris because we tell it to print the player name. The player score is 100 because we tell it to print the player score. And then is the player alive? Well, yes, it's alive. All right. So this is all for the basic things. I talked about this last module, so I'm not going to go really in depth in any more of this. And I want to move over to some math. So you can pause the video and type this in if you want to see this, because I'm going to delete it now. So the next thing I want to talk about is some basic understanding of math. And if you're completely lost on this subject, I'd recommend you go ahead and open the math documentation, just like this. As you can see, we have some things explaining this. The way you can find this is just type Roblox documentation and math. That's it. Just type Roblox documentation and then space math, and this page is going to pop up. It's also within one of the libraries. If you just check on the engine API, you can just go ahead and find math down here. And it says here, this library is an interface to the standard C math library, providing all of its functions inside the math table. So we have a quick summary here with some functions and properties, and then we have all of the different functions down here, which are available just to use within the basic math library on Roblox. I do know that some people make their own math libraries, or just extensions to them if they want something special. But using all of these functions would basically make you be able to do anything math-wise you want to do in Roblox. And I have not a single clue about half of these. I've never used them, so you don't need to check all of them and completely understand all of them, because well, you're most likely not going to use every single one. However, there are some major ones which I know that you are going to use. So we can start by going up to the functions, and we have something like the absolute, returns the absolute value of x. And we have all of these different things here. We have ceil up here, which returns the smallest integer larger than or equals to x. We have clamp, which returns a number between minimum and maximum. We have cos, of course, you know that from math. And then we have the log function, and we have minimum, maximum, and these numbers are very vital, because working with minimum and maximum is very normal in Roblox. And then you have the random function, and this is most likely the math function you're going to use the most. You also have random seed. You have math.round is also a very good one. Just rounds a number up to the most, like the closest value. You have sin, and you have tan for math, and you have the square root and etc. But the ones that you want to definitely keep in mind is I'd say round, random, min, max, and then something like log. You can also have a look at like ABS, some of the other ones up here, but definitely you want to have math.random, and I'll show you an example of using math.random in Roblox. So if you're coming from Python, you'd know that you have to declare the actual library that you're going to use, but in Roblox you can just type math, and this will just use the math library directly. I think it's even going to tell this, yep, it's going to say type of math, a library of math functions. So that's what comes up if you just type math. Oops. And then to get each of the functions, you just type dot, and then this will then be here is where we can you know, get all of our functions. You can see the only one that doesn't stand out as a function right here is just pi, because it's just 3.14. But the rest of these are actual functions right here. That all these that I just showed you before. And you have math.huge, which is just a set number, very, very large number. And yeah, you have all these functions right here. But if we try to do random right here, it's going to say it's going to ask for us about a maximum or a m or an n. We can go ahead and see what the m and m actually means. So the m default value would be 0, and then n would be 1. So when called without arguments, returns a uniform pseudo random real number in range of 0 to 1. Yeah, if we just go ahead and give this two values, would say math.random 1, 100, and then run this. Oops, what we need to do is we need to, of course, print this. You see it gives us 75 back, and this is because it gets a random number within 1 and 100. So if we go to run it again, we get a different number. We get 19, because it just picks a completely random one and has a 1% chance because it's 1 in 100. So this one is very useful. You can also use this to get a random thing from a table, which you are going to use in every single game project. So if we bring back the score table from before, like this, we can say local random value equals to, and then we have to do score first of all, which talks about our function or our table up here, sorry, and then do these, and then do math random 1 comma hashtag score. And I'll explain this. So basically, first of all, we're telling the engine to look within the score table, and then within this score table, as you can see in here, it's going to pick method random. It's going to pick one random element from hashtag score. And the way hashtag works is, I'll see if I can find a good explanation of it, but it basically just returns the function, the table in here. I'll show you what I mean if I just go ahead and print random value, and I go ahead and open right here, go ahead and print the value, because it basically just gets the values in here. I don't know how to explain it, but yeah, you guys get the point. You see it then picks 100 because it chose one random thing from this score table right here. If you go ahead and print again, it will most likely give us something else, 50. However, there is a 33% chance that it will pick the same thing because we only have 3 values. So it gave us all 3 of them, and then it's going to give us 10 again here, 2 times in a row, and 3 times in a row, and then it gives us another value right there. And if you want this to print multiple times without having to relaunch or rerun the game all the time, you can work something like I did before with a for loop, and we can say for I equals to 1 comma 100 do, and then we just copy this code in here, and then go ahead and do a small pass.wait. Go ahead and run this. You can see it's going to print us a bunch of values 100 times, and you've seen every time it says x2 is because it picked it 2 times in a row, 4 times in a row, 3 times in a row. So basically what we told the thing to do here is for 1 comma 100, so 100 times, we would do a small wait to not over stress the system, and then we'd find a random value within the table, and then we go and print that random value. So lastly, in this module, I'll go ahead and talk about some string conversions. So basically, when you have a string, you do local, we could say my string equals to hey, and we can also do local my number equals to 15. So when you do conversions, you want to use either toString like this or toNumber like this, and yeah, that is basically those two. So it basically it does what it says. It converts a number to a string up here, or it converts a string to a number with this one. So what we can do is we can say my string what we can do, we'll start by number. We'll say my number, and then we'll say local my number string. I just had to think about how I want to represent this. toNumber or toString, sorry, and then let's say my number. So I just had to think about this one shortly, but this is how we're going to do it, and then we can do the same thing up here. So we have down here, as you can see, we have the number 15 here, and then we're saying that with this number string here, kind of doesn't, the name doesn't really make sense, but you get the point. It will then convert the 15 to a string. If you go ahead and print this, print my number string, then we'll see it prints 15 down here. It's kind of hard to see, but it is a string. We can say, because it's changed that to a string, but you can't really see when you print it like this if this is a number or a string, but just know that this is a string. And you can also do this with booleans, and yeah, if we say instead of my string, if we within this string had like a number like 76,124. What we could then say is we could say local my, we'll just do the opposite here. My string number is to number my string, and printing this to, it will still not be able to show us, and in this case it doesn't even show us, and that's because I forgot to do the print. So we'll just do my number string comma my string number. There we go. So this, you can't really see the difference, but this first one will then be a string because we convert it to a string, and the next one will be a number. And of course you can't see it here, but this would be vital for your game if you're only allowed to pass in certain strings to certain things, or you need to just generally convert something, which you do quite a few times in your game actually. And then lastly, you can go ahead and take a look at this. I'm going to delete it now. We're talking about enums. So if I go ahead and quickly pull up the Roblox documentation on enums right here, then we can see what it says. So it says the enum data type represents an individual enum in Roblox. An individual enum can be indexed through the enums type via the name of the enum itself. So yeah, this is basically an enum, but what you want to do with enums is, say you wanted to it's basically like the backbone of a lot of stuff in Roblox. Say I wanted to set the camera to a set position in my game. Well, if I wanted it to set to the position of this position part right here, I'd have to, I'll show you what I mean. If I go down and play the game here, you see the camera would be, when I move my mouse like around like this on the screen, the camera follows my player. However, I want the camera to just be set to that position and not be able to change it. So like when I look around and such, and I have to use enums for this to work. So basically what I do here is I could say within my script, I'd have to use a local script, and that's because we want to change this on the actual client. So go ahead inside the starter player script, add a local script, and then we'll get the local camera by saying workspace.current camera, and this is basically the current camera of the player. And then we could say local player is game.players.local player. We can say if player, then we say the thing actually here gives us the example. So we'll just go ahead and copy this in, but we basically changed the camera type to enum.camera type.scriptable, and then we changed the camera C-frame to this part. We just have to change this to position part.C-frame. Go ahead and play this, and we actually get an error right here, and that's because let's go ahead and read the error. It says position part is not a valid member of workspace. All right, so I just changed the code quickly. So basically we just decline, or the get the position part up here within the workspace, and then if we have the player, then we just set the camera type to the enum camera type scriptable. If we do this, we could just say enum contains all enum objects, it says here, dot camera type, and you can see if I just say dot, you can see all these different things within enum, and there are a bunch of them. You can see if I just keep going down, like all of this is within enums. You can see a bunch of stuff is being handled within enums in Roblox, and a bunch of these different stuff you most likely never, like you're not going to use them, but they are here for your usage. But what I want to use in my case is I want to use camera type. You can see we got camera mode, we got a bunch of different stuff, but I want to use camera type and then scriptable, which makes it so that we can change the camera. If I go ahead and play this, then you can see the camera is then not following my player anymore when I move my mouse around either. It's stuck to this certain position because we used the enum property camera type and set it to scriptable. If I go ahead and check on my camera in here, you can see that the camera type in here, which is basically just an attribute within the camera, is set to scriptable. The camera subject is still the humanoid, but the camera type is set to scriptable, so it's in this set position. I can move my guy off the screen without the camera following him. You can also see that you can change the FOV, which you can also use by using enums, I believe. I don't actually remember if you use enums. Don't fact check me on that, but it's been a long time. But that's also something you can change with the camera. So that's basically some of the enum stuff. You guys get the point with enums. As I showed you here before, it handles a bunch of stuff. Key code, which is used in user input service, which is right down here as well. You have some ID stuff, core GUI type, render priority, material, animation priority, access, font, lim, genre, style, intent, status, all this stuff, GUI type, bin type, quality, rig type. You got a bunch of stuff, chat mode, font size, gear type, like all of this stuff. Everything in Roblox basically runs on this enum thingy. So lastly, we'll go ahead and play a sound in Roblox just to show you guys how that works. So the way that you get a sound, or the way you make a sound in Roblox, if we just wanted to play for the player, we want it to run in the client code, which means it's only gonna replicate for that player. If we want the sound to play on the server, we'll play it in the this script right here. So in this case, I just want it to play to the actual player. So I'm going to make a sound by saying local sound equals to instance.new, which basically just makes a new instance of whatever we put in it here. And I'm just gonna say I want a sound, but I could also say I want a bass part, or just I think that's just called a part, and then, you know, particle emitter, all that stuff. But I want a sound in my case, and then we can give this sound some properties. We could say that the sound.sound ID, and then RBX asset ID, like this, is the way that you classify ID. And then I'd have to put a number after this. We'll go ahead and do that in a second. And then we can do a volume of like 0.3, 0.5 actually would be better. We can give it a parent. So you can say that it should play from the workspace. And then we can say class.wait5, sound play. We can also do sound.loop equals to true. So basically what all this does right here is that you have this sound, and we then give it a certain ID here in a second. We give it a set volume, we give it a parent, and we then make sure that it's looped. So whenever we play it after the 5 seconds, it's going to keep repeating and keep playing over and over and over and over and over. So what I'm going to do in my game is I'm going to just get a random sound, and I have a sound right here which we can tie, just like a whoosh sound effect, and I have it right here in the creator store. And what I'm going to do, I'm going to the URL up here, or the 3 dots, not even the 3 dots. You go to the URL up here, you copy these numbers, which is the asset of it, and you just paste them right there. So if we go ahead and play the game now, we should wait 5 seconds and we should hear the sound play. Turn my volume up here. You see the sound plays repeatedly over and over and over and over. So then it's going to keep playing, and this sound only plays for me. The way we can actually fact check this is, you can see we're currently on the client. If I then switch it to the server in a second here, you can see I can hear nothing now because I'm on the server. Nothing's being played on the server. If I go back to the client, we should hear it again. Right there, it's in the client again. So this is how you play sounds for the client. And you can mess around with sound service. A bunch of new stuff just got added to the sound API. So you can make some really cool projects with it. And this is also the way you play background music in the game. You just handle that on the server instead. So yeah, this is basically all for the third module of Roblox. Hopefully I give you guys some understanding of a bit of data types and loops. We can quickly also go over one more type of loop, which is a while loop. So you can do while true do. And this, while true in this case would just be while everything is correct, while the game is running, kind of, you could say. Then do this code. We can also do while test.wait 1 do, and then we could do print hi. So what we should see here is that for every second, every time we wait 1 second, we should do the code underneath, which is just printing hi. So it's going to do this, and this it would do indefinitely. You could also set it to a really high number. So you could use the math.huge number, which is just a massive math number that I talked about earlier. And it's going to run whatever code is within the start of the loop and then the end. It's going to run this code with the arrow here infinitely, basically, with this number. I mean, it is going to stop at some point, either when this number runs out or when you leave the game. However, if you just do test away 1, or you just do while true do, then essentially, oops, no, I'm messing on it. If I just do up here, while true do, this is essentially just infinite. But this will also bug out the game if I go ahead and start this, because, I mean, we could try to run the game. You see, this is now lagging. And the reason why this is lagging, you guys will probably try this at some point in your game. And you might actually lose some progress because Roblox can't even save it. You see, actually, it does something for me now, but I can't move the thing around, and it's really, really buggy. And it's because we just told it for every single tick, basically, it should print high with no delay in between. And then it's just going to do this really, 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 really fast. And that's basically going to bug out the engine. So either you get where it saves itself by doing script execution, got like overhauled or whatever it says, or it just crashes your thing. So right now it's looking like it's just going to crash Roblox Studio because it's not responding. As you can see, it says Roblox Studio not responding, but there we go, it kind of stopped itself. You can see it in that time, it printed itself about 6,000 times. It printed high within every single tick, basically, as you can see. So this is the hour, this is the minute, and this is the second, and then this is like the millisecond, one hundredth of a millisecond right here. And you can see it prints every single time, and it prints multiple of these every single hundreds of a millisecond. So it prints really, really, really fast. And then it gives us this error where the exhausted allowed execution time, which basically saves the progress that you might have lost, because Roblox basically says this is too much, and it's going to time out our script. So that's another way of looping in Roblox Studio. For the next module, which I'll be getting into the next video, we'll talk about some more intermediate code, like some game services. We'll talk about what the differences are of scripts, local scripts, and these things here, module scripts. And then we'll also talk about some object properties / attributes. We'll get more in depth with that, kind of in the same genre of enums, but we'll get a bit more in depth of the actual hard attributes and properties. And then we'll talk about what the actual difference from doing something client-sided and server-sided is. And that's basically all for the next module. So thank you guys for watching, and I hope you have an amazing day.